Space disasters and close calls are a riveting aspect of human space exploration, representing moments when missions teeter on the brink of catastrophe, but either narrowly avoid disaster or suffer dire consequences. These occurrences highlight the inherent risks of space travel and the thin line between success and failure in such a hostile environment. The study of space disasters and near misses is not only a chronicle of past events, but a crucial part of learning and improving safety protocols for future missions. Understanding space disasters and close calls is essential because they offer invaluable lessons that drive advancements in technology, engineering, and operational procedures. These events help foster a culture of safety and preparedness, ensuring that each mission benefits from the hard-earned experiences of the past. They remind us of the bravery and resilience required from astronauts and ground teams as they confront the unknown. A notable example is the Apollo 13 mission in 1970, which became a successful failure. An oxygen tank explosion crippled the spacecraft, forcing NASA to innovate rapidly to ensure the crew's safe return to Earth. This incident underscored the need for reliable life support systems and contingency planning, which have since become standard in mission design. Another significant event was the 2003 Space Shuttle Columbia disaster. The shuttle disintegrated upon re-entry due to damage from foam debris, revealing critical vulnerabilities in shuttle design and risk assessment. This tragedy led to the retirement of the shuttle program and a re-evaluation of safety protocols and vehicle design. Opinions about the importance of studying these incidents often emphasize how they function as pivotal learning experiences. NASA's Lessons Learned program embodies this philosophy, systematically reviewing missions to extract practical insights. Conversely, some argue that the focus on past failures might overshadow the mission's overall achievements or lead to overly cautious approaches that stifle innovation. Challenges in this area include balancing the drive for cutting-edge exploration with the need for rigorous safety measures. Alternative viewpoints suggest that as space exploration becomes more privatized, varying risk assessments and profit motives could complicate standardization efforts. This focus on disasters and close calls is interconnected with other aspects of the main topic, such as technological innovation, international collaboration, and public perception of space exploration. These events shape policy decisions, fuel technological advancements, and influence risk management strategies. As a result, understanding and addressing these incidents is crucial for the sustainable and safe advancement of human endeavors in space. A historical overview of major space disasters delves into the significant incidents that have marked humanity's journey into space, providing crucial insights into the challenges and triumphs associated with space exploration. This concept involves evaluating past mishaps to understand the inherent dangers of space travel, emphasizing the necessity for rigorous safety protocols and technological advancements. The significance of this overview in the context of space disasters and near catastrophes lies in its ability to guide present and future space missions. By learning from past mistakes and close calls, the aerospace community can implement changes to prevent similar occurrences, thereby enhancing the safety of astronauts and the sustainability of space missions. Two prominent examples illustrate the impact of these historical events. The Challenger disaster in 1986, where the space shuttle broke apart 73 seconds into its flight, killing all 7 crew members, underscored failures in NASA's program management and the need for improved communication and safety practices. Similarly, the Columbia disaster in 2003, where the shuttle disintegrated upon re-entry due to damage sustained during launch, highlighted the importance of thorough inspections and better safety protocols. Supporters of learning from these disasters argue that each incident, while tragic, serves as a pivotal learning opportunity. Advocates believe that by thoroughly analyzing these past events, agencies can identify vulnerabilities and innovate technologies that improve the reliability and safety of current space missions. However, challenges in this area include the potential for complacency and the inherent risk of unforeseen technical failures. Controversies often arise regarding the allocation of funds towards space exploration when such disasters occur, raising questions about the balance between exploring new frontiers and ensuring the safety of those who venture into space. This historical perspective is intrinsically linked to the broader narrative of space disasters and their near-miss counterparts. Understanding past failures informs the development of new technologies and safety measures that can avert future catastrophes. It also influences policy decisions and international collaborations, as shared experiences bolster collective knowledge across various space programs. In conclusion, a historical overview of major space disasters serves as a critical educational tool, reminding us of the perils of space exploration while paving the way for more secure and successful missions in the future. By acknowledging the lessons learned from these tragedies, the space community can continue to push boundaries with a heightened sense of awareness and responsibility. Technical and human factors are pivotal aspects when examining the causes behind space disasters and near catastrophes. These factors refer to the technological and engineering components of space missions, as well as the human decisions, actions, and interactions that can lead to potential failure points. Understanding these elements is crucial because they form the foundations of safety and success in space exploration. Identifying and mitigating them can prevent disasters and save lives while advancing our knowledge and capabilities in space. The significance of exploring technical and human factors lies in the potential to learn and adapt. Space missions operate under extreme conditions where the margin for error is negligible. As the cosmos becomes a domain for humankind's aspirations, facing the challenges of technical malfunctions or human error is inevitable. By studying these factors, the industry can implement safer protocols, design more reliable systems, and train astronauts to handle crises effectively, ensuring missions are successful and lives are protected. One specific example that highlights the importance of these factors is the Apollo 13 mission. In April 1970, an oxygen tank explosion crippled the spacecraft en route to the moon. The ensuing crisis was managed through a combination of technical problem-solving and remarkable human ingenuity. NASA engineers and astronauts worked together under immense pressure to devise a solution that brought the crew safely back to Earth. This incident underscores how technical failures, when coupled with expert human intervention, can become a pivotal learning opportunity rather than a tragedy. Another example is the Space Shuttle Challenger disaster in 1986. The catastrophe was attributed to a technical fault, a failure of an O-ring seal, and was compounded by human factors, including management's decision to launch despite known risks. This tragedy prompted significant changes in NASA's safety culture and engineering practices, emphasizing the necessity of addressing both technical issues and decision-making processes. Despite the apparent necessity of addressing these factors, challenges and controversies exist. Some argue that too much emphasis on technical redundancy can inflate costs, while others contend that human error is inevitable given the complexity of space missions. There's also debate about the balance between automated systems and human control in mitigating risks. Ultimately, addressing both technical and human factors is interwoven with the broader endeavor of improving mission design, execution, and safety in space exploration. These considerations influence protocols, training, and technology development, ensuring that as we push further into space, we do so with foresight, preparedness, and resilience. The analysis of famous near misses in space exploration delves into incidents where missions came perilously close to disaster, but ultimately avoided tragedy. These situations are critical for understanding the potential hazards of space travel and for improving safety protocols. By examining these near catastrophes, we can draw valuable lessons that contribute to the safety and success of future missions. The importance of this analysis lies in its ability to transform almost failures into learning opportunities. Each near-miss story is a testament to human ingenuity, resilience, and the relentless pursuit of knowledge. They remind us of the extreme environment of space and the unpredictability that comes with venturing beyond Earth. Through understanding these events, space agencies can refine their technologies and strategies, better preparing for unforeseen challenges. One poignant example of a near miss is the Apollo 13 mission. In 1970, an oxygen tank explosion crippled the spacecraft, forcing NASA and the astronauts to abort their mission to the moon. The team ingeniously used the lunar module as a lifeboat and improvise a solution to remove carbon dioxide from the spacecraft, ultimately returning safely to Earth. This incident not only highlighted the importance of robust contingency planning, but also showcased human perseverance under pressure. Another example is the Soyuz T-10-1 launch in 1983, where a rocket caught fire on the launch pad. The escape system activated just in time to propel the capsule away from the explosion, saving the lives of the two cosmonauts aboard. This event reinforced the need for reliable emergency systems in spacecraft design. Opinions supporting the examination of near misses emphasize their role in enhancing safety protocols and fostering innovation. Each close call pushes technology forward, making space exploration safer for future astronauts. However, challenges and controversies exist, such as the difficulty in balancing risk with the cost of building redundancies and fail-safes into mission designs. There is also debate over how much risk is acceptable in the pursuit of knowledge and exploration. Analyzing these near misses connects to the broader topic of space deceitors and close calls by providing a foundation for developing preventive measures. Lessons learned from these events influence policymaking, engineering processes, and the overall approach to managing risk in space exploration. By understanding and applying these lessons, the space community can better protect lives and ensure the continued success of missions, pushing the boundaries of human capability.